Now what's this question? This is given in 1996 GATE. They are saying that 1000 KB memory is managed using variable partitions. So they are clearly saying that it is not fixed partitioning, it is variable partitioning, but no compaction. No compaction means there could be holes possible over time, right? And it is currently holding two partitions of sizes 200 KB and 260 KB, which means total available is 1000 KB, right? And already 200 KB is allocated and then 260 KB is allocated. Therefore, what is the free space available? 1000 minus 460, which is 540. So 540 KB free space is available. Then they are saying the smallest allocation request in kilobytes that could be denied for is for, which means if you have 540 KB, then what are the various combinations in which you could put 200 KB and 260 KB in such a way that we get the resulting partitions as small as possible. That is what they are asking. So what the question is, we have totally 1000 KB, right? And now where are you going to put this 200 and 260 here in such a way that the resulting partitions are going to be as small as possible, right? That is the question. Now how can you solve it? So one thing is, if you have to get smallest partitions possible, then there should be more parts, isn't it? If there are many parts in the memory, many holes in the memory, then the hole sizes will be as small as possible, right? So using these two processes of these sizes, how many maximum partitions can you get? If you put both of them together here, right, I mean 200 and 260 directly, then only one partition, right? If I put one here and the other somewhere here, see, one thing is 200 260. If I put them like that, only these two are here, only one partition we get, and that partition or the hole will be very big, right? And the other one is, if I put 200 here, right, and then maybe 260 here, right, then I get two partitions, two holes, right? And even if I get two holes, one hole will be bigger than the other, right? So other way is, maybe if I put 200 and 260 in such a way that 200 is here and 260 is here, I'll get many partitions. The maximum number of partitions possible in this case is 3. You cannot go beyond 3. And now we have to see that all these 3 partitions are as small as possible, right? So how can 3 partitions be as small as possible? It can be possible only when 3 partitions are of equal sizes. In case if these 3 partitions are not of equal sizes, then what happens is one partition which is smaller will contribute to the other partition which will become bigger, right? Then if you even have one bigger partition, that will be able to allocate, that will be able to hold a bigger process. Now they are saying, what is the smallest process request that could be denied, which means what is the way in which you can organize it in such a way that we get smallest number of partitions, smallest size partitions. So one thing is, have as big partitions, as many partitions as possible. In this case, how many partitions can I have at maximum? 3 partitions. And second thing is, these 3 partitions should be as small as possible. If that has to happen, all the 3 partitions have to be of equal sizes. If they are unequal sizes, then definitely I'll get one bigger partition. If I have to see that the partitions are as small as possible, they have to be of equal sizes. It is logical. I don't know whether you are following it or not, but please think over it. It is not actually a computer science question, it is an aptitude kind of question, right? So it is like this. If you have a circle, now if you have to divide it into 2 parts, right, in such a way that the parts are as small as possible, right, both the parts, then the equal size part, you have to divide into equal size, isn't it, right? So it is a kind of question like that. I think you got it, right? In the sense, I'm saying that we have 540 kilobytes, and if I want the partitions to be as small as possible, then we should divide it into only equal size partitions, right? So if I divide into equal size partitions, then I'll get 180 here, 180 here, 180 here, right? So if I get any request for 181, that will be denied. Therefore the smallest request which could be denied is 181, right? And if 181 can be denied, obviously 231 can be denied, 541 can be denied. But then I need not go till that point. Even 181 is the smallest one. Now why not 151? If 151 has to be denied, right, then all the partitions, all the three partitions possible have to be smaller than 150. If all the three partitions have to be smaller than 150, then 150 is, 151 and 150 is allowed, right? Then if I have three partitions of size 150, then it is going to be 450 size, right? But then the total available is 540, not 450, isn't it? Now if that is the case, are you getting this? If this one has to be denied, then every partition has to be of size 150. If every partition is of the size 150, then the total free size will make up 450. But 450 is not the total free space. This is 540, isn't it? Therefore, 181 is the answer. Got it? Now in the same question, let us assume that they are asking what is the largest process size that could be denied? What is the largest request that could be denied? Then if you have to see the largest request that could be denied, then maybe this one is the right organization, right? Which means 200 will be here and 260 will be here and the complete 540 will be here, right? So therefore the largest request that could be denied is 541. If anything is less than 541, that could be allocated, right? So if they are talking about the largest request that could be denied, try to have one single hole with as big size as possible, then it will be able to hold the largest possible size, and you do +1, that will be denied, right? And if they are talking about the smallest allocation which will be denied, then you are going to make it as many partitions as possible, and each partition is going to contain as small size as possible, right? Fine.